Okay guys, today we only had one vocabulary word to discuss, and that was least common denominator, or the LCD. Now when you were reading the definition for LCD, what did it sound like? What did it seem like it was a definition of, Haley? It sounds exactly like least common multiple. In fact, I'm going to go as far as to say they mean the same thing, except when you're talking about the LCD, you're talking about something specific. What is it? Fractions. And the D is the denominator. Okay? So yesterday we talked about finding the LCM of just numbers. Okay? You were given 2 or 3 numbers and said find the LCM or find the first 3 common multiples. Today we're taking that terminology and talking specifically about finding the LCM of fractions, okay, of the denominators. Okay? Any questions about understanding what that term means? All right. Today we are going to look at comparing fractions. So on your notes, put today's date, and I want you to put LCD, comparing fractions. Alright, for all of these we're going to be looking at greater than, less than, or equal to. So let's look at the first set of fractions. This is what it's going to look like in your book. You're going to be given 2 fractions, and it's going to have kind of this grayed out circle in the center. And I'll tell you to compare the fractions. When we're looking at comparing the fractions and using the LCD, how is using the LCD going to help us figure out which one is greater than or less than? What's that going to do? Why would we find the LCD? Caleb, what do you think?
So we can compare which one's bigger and which one's not.
True, but what is the LCD going to help us do with that? How are we going to use that? Max, what do you think?
To make the numbers as small as we can,
To make,
you can compare them.
okay, Haley?
Make the numbers so that you can compare them, but make them equal.
Okay, keep talking to me. You're saying making them equal. What do you mean?
Like, turn them into...
You're on the right track. Gavin?
Turn them into both sides that they can both go.
Okay. So if I find the LCD, are they both going to have they're both going to have the same what? They're both going to have the same denominator. When do we do that? When we're doing what with fractions? Do you remember? What about adding and subtracting? With unlike denominators, can you do that?
Not in this case.
No. If you remember with fractions, if the denominator was the same, you could add or subtract straight across. But if the denominators were different, you had to find the common denominator and switch the fractions over. Find equivalent fractions with the new denominator, right? Okay. So if we're looking at, specifically here, we're going to be looking at 8 and 7, right?
Yes.
So if we're thinking about putting those 2 numbers in a division ladder, is there any number that will go into both 8 and 7?
No.
No. So what did we learn yesterday that we have to do? We multiply them together. So what's the new denominator? 56 for both of them, right? Okay, you should be writing this in your notes. So we started talking about when we were shifting decimals to divide. And we were talking about whatever you do to the divisor, you have to do it to the dividend, talking about how many times you shift the decimal, right? And I said, if you remember, when you talked about fractions, whatever you do to the bottom, you gotta do to the top. Okay, this is that moment. Looking at 3/8, what did we do to 8 to get to 56?
Times it by 7.
We multiplied by 7, so what do we have to do to the top? To get what?
21.
21. So on this one, we multiplied by 7, the 3 and the 8. So then looking over here, what did we do to 7 to get 56?
Times 8.
Multiplied by 8. Great. So what are we going to do?
Multiply 4 by 8.
4 times 8, which is
32.
32. Now, when the denominators are the same, you can compare them easily. Which one is greater?
4 over 7, or 32 over 6.
Good. Okay. So in our kind of our scratch work, if you will, the 32 over 56 is greater, but if we come back to our original problem, 4/7 is greater than, or we would read this as 3/8 is less than 4/7. Question? Sophia?
So, what if you already, like, you knew that it was, if you, like, you know 8 is greater than 7, so you would know that there would be more of this type of fraction.
Just because the denominator is greater doesn't automatically make it a bigger fraction.
But what if you have to do that, you have to do that.
Okay? So this is going to be another one of those times where if you know it by looking at it, that's fine. And we're going to talk towards the end exactly what I want your paper to look like, okay, when it comes to the scratch work. Nani?
I just thought like a 5.
Okay?
Because there were 7 or bigger slices, and then you put the word 4.
Sure. And somebody last hour was talking about, well, if you're looking at these, you know, the closer the numerator is to the denominator, the bigger the number, right? Well, there's only 3 away from, when you look at 4 and 7. If you look at 3 and 8, there's a distance of 5, you know, or, you know, in Nami's head, he's thinking about cutting up, you know, pizza slices and how big the pieces will be. So that's good. You're using visual things. You guys have done that since, like, first grade, probably in kindergarten. So that's good. And we're going to get to how I want you to show your work, okay? All right, now I want to show you a trick. We talked about finding the common denominator, and that's very useful. But I want to show you a trick when we're talking about comparing fractions, and we don't have to find the LCD, okay? Yeah, it's another trick. So I'm going to use the same fraction, the same comparing. Which one did we know was bigger here? Okay, so we know that this one's bigger. All right, so when I do this trick, we know what the answer is. What is 8 times 4?
32.
What is 7 times 3?
21.
Which of these two numbers is bigger?
32.
Okay. Last hour, as soon as I started writing this, the X there in the middle, they were like, oh my gosh, we know this! It's that simple, okay? Nani?
Connor was doing that before you.
Okay, and that's great, and that's great. And some people have never seen this before. Some people, it's like, oh, yeah, I remember, but it just took seeing an example of it to remember, okay? All right, now, we're going to do a couple of examples together, and then we're going to talk about your work. Now, I'm going to do the examples on this piece of paper that looks like notebook paper. All right, so if I have my first problem that I'm writing on my paper, I'm putting my fractions like this. Am I trying to squeeze the numbers onto one line? No. I'm using 2 lines for one problem. That blue line going across your paper is, you're kind of using that as your fraction bar, all right? Yes, this is 7 over 12. Sorry, my pen went crazy. And then I'm leaving that gap in the middle, because that's where I'm going to put my inequality symbol. So if I go to do this, and yes, I know that there are ones that you can look at and say, well, I already know which one's greater than or less than, without even having to think about multiplying. That's going to be fine. But on the ones that you can't figure it out just by looking at it, this is how you're going to show your work. So if we think about the multiplying trick, what's 8 times 7? 56. So I took that little 56 up here. What is 12 times 5? 60. And I put that over here. Which one's bigger?
5/8.
Right, the 60 or 5/8. So then in the middle of my two fractions, I'm going to put the greater than symbol. By doing this, I'm showing my work of my multiplication, and I'm putting my answer. So 5/8 is greater than 7/12. This is what it's going to, yes, this is every bit of what you're doing today. Okay, nope. This is every bit of what you're doing today. Okay? You're welcome. Let's do one more together.
Finding your way.
One more together. So 2/3 and 4/9. Doing that cross multiplication, 3 times 4, 12. 9 times 2, 18. Which one's bigger? 2/3. Okay? Any questions about how to do these problems? Okay, do you guys understand the trick of multiplying diagonally?
I need a worksheet today over this.
Your assignment. Yes, Haley.
Is there equal, like, if the numbers are equal, would the problem?
Yes, that is a very good question. Haley asked, well, when you multiply and these two numbers are equal, that means you're going to put what symbol here? Equal sign. Good. All right, so your work today is page 683, so it's in the back, and it's under the lesson 4-6 section, and you're going to be doing numbers 1 through 20. Any questions?